video is going to talk about section 4.2, and we're going to begin learning about experiments. We won't get all the way through 4.2 today. It's just the introduction. Okay, so what I'm going to have you do first is act as if you were in class. You should be able to answer 1 through 4 on your own. It's okay if you don't have a perfect understanding of what it's asking for. I will go over that just like I would if you were in class afterwards. Okay, so what I want you to do is pause the video and try 1 through 4 for me, please. Okay? When we talk about an observational study versus an experiment, the difference is whether we're applying what's called a treatment. And a treatment is just something that we are trying to see if it has a change that takes effect. So because in our example, that change that was happening wasn't required, it's an observational study because they're just measuring what happened. They're not sampling people and having some of them go to this ACT prep course and some of them not. Okay, so this one is just an observational study. Okay, explanatory variable and response variables, we've already talked about those in terms of a graph, but they also have meaning in terms of an experiment. Okay, so the explanatory one is what is used to predict what we think the cause may be, and then the response variable is the outcome. I want to really emphasize, though, ACT prep class is not a explanatory variable. It's whether or not they took that ACT prep course. Okay, so you have to have this status, whether they did it, and that's what we're really measuring. Okay, this next part kind of has a little bit of tie to last chapter. We talked about correlation quite a bit. Correlation is not the same thing as causation. So just because 2 items are related doesn't necessarily mean that one causes the other. So there might be other underlying factors that go into play. In order for us to actually show causation, we have to do an experiment. Okay? And don't worry about this quite yet, but I do want to talk about those things that might be playing a role. Those are called confounding variables. So motivation, like students wanting to do well on the ACT, may study more. Okay, that could be something that causes their ACT score to be higher, not necessarily the prep class in general. If they're college bound, their ACT score may be higher because they put in the work. They know they need scholarships or a certain ACT score to get in. The time they spend after school studying. The number of classes they have, because if you take some of the higher level math classes, you may do better on the math portion of the ACT. Same thing goes with maybe if you're in an honors English class, maybe that's a reason you did better on the English portion, and it had nothing to do with the prep class. So these are ideas, and you may have had different ones, something similar, but the big idea is that these are called confounding variables. They're other explanations other than what we're actually measuring. Okay, so the goal in setting up an experiment, and that's where this comes in, is we have this explanatory variable that we want to decide if it is causing the ACT score to go up. But we also have these confounding variables that may be playing a role as well. So our goal when we're setting up an experiment is to eliminate the confounding variables and get rid of as much as we can, or control for as much as we can, to determine if really that correlation between the prep course and the higher ACT score was actually the only cause of that increase. Okay? So then on number 5, what I want you to do is try to design an experiment that would allow us to determine if the ACT prep causes an increase in ACT scores. Okay, so try to be as thorough as possible in explaining this, and then we'll chat after you give it a stab to go over kind of what I'm looking for here. Okay, so pause the video and try that for me. Okay, so here's an example of how it could have looked. Randomly choose some number of juniors. It wouldn't have to be 100. In fact, in a school our size, 50 might be appropriately large enough, because 100 juniors would be nearly half of our juniors. And we don't probably need a sample that large. But it says we got to choose people to be part of the experiment. So we want to do that first. Okay, once we decide who's part of that, we're going to split the group in half. We want to make sure that half take the prep course and half do not. So that way we're controlling that it wasn't that these people were volunteering to take it. We are making half of them do this and half of them do that. Okay, but really important here is this word randomly split. Okay, and it's not something you have to add in, because what we're going to do is draw out this kind of diagram here in a minute, so you don't have to adjust your paragraph. We'll talk over the process here just in a second. Okay, but the random part is important. We don't want people to choose that they're taking the prep. We want to randomly assign them. Okay, this is going to take part of the other variables where it could have been talking about motivation. I'm going to go back here real quick. Okay, people who are motivated may want to take that ACT prep, but we're taking that out of there because we are assigning it randomly. Same thing for these other examples. Okay, and then from there, we are going to have them actually take the course. So we're applying the treatment, okay, or the thing that's being changed. And then one month later, they're going to all take the ACT. They did this example with an SAT, but the ACT, and compare the scores between the two groups. So here's how it works in general. We're going to take our experimental units, so those are the people that we want to place in the experiment, and we're going to randomly assign them to however many groups that we have. Okay, there were 2 here because we had half of them take the ACT prep course and half of them not take the ACT prep course. So we were splitting it in half, which would mean 50 go here and 50 go here, and then the treatment itself was the course, and then we compare the results. So what we're going to do in the space that you have below here is we're going to fill this part out. And you have this diagram on the back side of your paper, so you don't need to write that. What you're going to write is how it applies to this specific example. So the experimental units, those were your 100 juniors. Okay, and what we're going to do always with those 100 juniors is randomly assign them. Okay, so in this diagram, that is its own box. And that can be honestly written on these lines as well, but it has to be included somewhere on this picture. Okay, and then what we're going to do is split them into 2 groups. So if we have 100 juniors, we would have group 1 be about 50 juniors, and group 2 is going to be the other 50 juniors. And then this first group, we're going to apply the treatment to. We're going to have them do the ACT prep course. And the second one, we're going to apply no ACT prep course, so no treatment. And then after we've done that, we'll compare. In this case, our results are talking about the ACT scores. And that's a basic setup for any experiment. Okay, what's really important is when we're at this stage where we're splitting them, these groups should be roughly equal based on whatever number you're starting with here. With randomly assigning, we should have some sort of random number generator applied at that stage. Okay. On the back side, this is the diagram, like I said, that is filled out, gives you a reminder of the process and what pieces I want when I ask you to lay out the mapping for an experiment. And we're just going to fill out some vocab. Some of these we've already talked about, but it's pieces that are involved here and pieces that we've mentioned on the front page. So a what observes of individuals and measures variables of interest but does not attempt to influence. Okay, so if it does not attempt to influence, that means there's no treatment. So that's just an observational study. Okay, and these can be useful. There's 2 major types. There are retrospective meaning the data analysts are looking at data that's already been collected, okay, it's been in the past, and then prospective is something they're going to watch into the future. Okay, and a what measures an outcome of the study. So both these next two are talking about our variables, the response variable and the explanatory variable. So the response is the one that measures the outcome of a study. And then the explanatory variable may help explain or predict the changes in the response variable. Okay, what occurs when two variables are associated in such a way that their effects on a response variable cannot be distinguished from another? Okay, so this one's kind of a tricky one, but the big thing here is the effects cannot be distinguished. So this is the one where we have too many variables that are muddled together and we can't determine which one is causing which one to happen. So this is confounding. And then the variables themselves are confounding variables. A blank deliberately imposes some treatment, so this is the one that where there is a treatment on individuals to measure their responses. That's an experiment. And the condition that's applied to those individuals is the treatment. Okay. A blank is the object to which a treatment is randomly assigned. Okay, so these are the who, and those are our experimental units. Okay, we've used words like units or members. Oops. Because remember, we don't always talk about people. A lot of times when experiments are set up, they do deal with people, but in any study, it doesn't have to be a person when we're talking about the object of a study. In an experiment, what means that experimental units are assigned treatments using a chance process. Okay, so this is the most important thing when we're splitting up our groups, is we have to have random assignment. And now we're just going to see if you can take those vocab terms and apply them to some questions. Okay, so I want you to pause the video and take a stab at 1 and 2. When you're done, we'll go over your thoughts. Okay, this first one was an experiment because there was a treatment present. Okay, you were randomly divided into Ben's house or Jerry's house for the party. Okay, that was going to determine the cell signal into those different groups, but it was randomly assigned, and that's important. Okay, the second one was talking about books and its relation to academic success. It was an observational study because no treatment was applied. Okay, it was just looking at book presence and academic success. They weren't randomly assigning some people to have books in their house and some people to not have books in their house. Explanatory is the number of books in the home, and the response is the academic success, whatever measure they were using for that, maybe grades or a standardized test score. And then the last one, it says, explain clearly why such a study cannot establish cause and effect. Y'all, we cannot determine cause and effect or causation without using an experiment. That experiment is going to control for some of those confounding variables that may also be playing a role. So you may have had some example other than this, but here's the suggested one. It said maybe students with more books tend to study more, and studying results in greater academic success. Okay, I just needed you to come up with some example of a confounding variable that could be causing it other than just the books in the house. And that is it for today. We'll finish talking about more with experiments and finish section 4.2 next time. But you do have an assignment on sapling that does get you started on some of these vocab terms. Please come see me if you have any questions.